need to classify an image using a simple signature pattern in DSPy. We'll define a clean input-output signature for dog breed classification, then use it to make a prediction from a URL, all with just a class definition and a single function call. The example shows how DSPy handles image inputs through its image field type.
Class dog picture signature, DSPy, signature. Output the dog breed of the dog in the image. Image 1, DSPy. Image equals DSPy, input field, desk equals an image of a dog. Answer, SDR equals DSPy. Output field, desk equals the dog breed of the dog in the image. Image URL equals https://pixum. photos/id/237/200/300. Classify equals DSPy. Predict dog picture signature. Classify image 1 equals DSPy. Image from URL image URL.
This demonstrates signature-based task specification, where a Python class defines the input-output contract for an LM interaction using declarative field definitions. The dog picture signature class encapsulates the task requirements, an image input and breed name output, while DSPy, input field and DSPy, output field, provides semantic metadata about each field. The key distinction here is that the signature describes what the LM should produce, not how to prompt it. The pattern works by separating task definition from execution. The signature class acts as a schema that DSPy uses to structure the LM call, while DSPy, predict, binds this schema to an actual prediction. When executed, the framework handles the conversion of a URL into an image object and passes it to the LM, but the signature itself remains a static declaration of the expected behavior. This design allows the same signature to be reused across different inputs or modules, as long as they conform to the defined interface. This approach replaces manual prompt engineering with structured, reusable definitions. Instead of embedding task instructions in a prompt string, you define the task's shape in code, which DSPy then compiles into an optimized prompt. The trade-off is a slight abstraction layer, but the benefit is cleaner, more maintainable code, especially useful when building pipelines where multiple LM calls need consistent input-output contracts. For tasks like this image classification example, it ensures the LM interaction remains explicit and type-safe. Let's break it down line by line.
Class dog picture signature, DSPy, signature.
This creates a signature class inheriting from DSPy, signature, defining the input-output structure for an image classification task. The signature declares an image input field and a string output field, establishing the expected data flow for this specific prediction.
Output the dog breed of the dog in the image.
This docstring defines the signature's purpose, generating a dog breed classification from an image input. It serves as both human-readable documentation and a directive for the DSPy framework about the expected output structure.
Image 1, DSPy. Image equals DSPy, input field, desk equals an image of a dog.
This defines image 1 as a typed input field using DSPy. Image, with a description specifying it must contain a dog image. The type annotation ensures the DSPy framework will handle this parameter as visual data rather than text.
Answer, SDR equals DSPy. Output field, desk equals the dog breed of the dog in the image.
This defines the signature's output field as a string named answer, using DSPy, output field, to specify that the language model should return the dog breed as structured text. The description parameter provides explicit guidance about the expected output format.
Image URL equals https://pixum. photos/id/237/200/300.
This hardcodes a test image URL from Pixum, photos as input for the DSPy prediction pipeline. The fixed 200x 300 pixel dimensions ensure consistent input size for the demonstration.
Classify equals DSPy. Predict dog picture signature.
This instantiates a predictor using our dog picture signature as the execution template. The DSPy predict class converts the signature into a callable that will process the input image and return the structured output defined in the signature.
Classify image1 equals DSPy. Image from URL image URL.
This invokes the prediction pipeline by converting the URL into a DSPy image object and passing it to the classify predictor. The framework handles the image-to-text transformation internally, returning the breed prediction as a string based on the dog picture signature definition. This single line triggers the complete inference workflow from image input to structured output. DSPy signature-based prediction. This code defines a typed signature, dog picture signature, that declares an image input and string output, with classify instantiating a predictor bound to that signature structure. The image URL must be wrapped in DSPy image from URL to match the signature's expected input type. This pattern shows how DSPy enforces type contracts between data and predictors through signature definitions.
The image that never loads reveals the perfect classification.